Hi everyone, and welcome to electricity lesson number 4. This is part 2 of our circuit simulation lesson. So today our focus will be on um, which types of materials are conductive and which types of materials are non-conductive. So first we're going to be doing the phET simulation software. We're going to be using that, so you can click on the PDF attachment, click right over here on the globe, and it will automatically launch the simulation program. And then after we've done this lesson, where we're just going to basically make a few of these, we're going to be using the program, making this circuit, creating a gap right here, okay, and switching out different items to see if things are conductive or not conductive. Okay, and then after that, we're going to do, after you practice that a little bit and you kind of get it all in your brain, you can try out the quizzes assignment, and the assignment is called Conductive versus Non-Conductive Materials. Okay, so just in general, we know from our properties of matter and properties of metals and nonmetals, we actually discussed this before, right? So electrical conductors, here's a list of them, okay? These are all metals. There's silver, there's gold, there's copper, and there's steel, okay? Now seawater is also, it's actually considered a semiconductor, like a half conductor. Why is it? So pure water is not a conductor, but because of dissolved minerals, and minerals are just metals, so it has these little dissolved metals inside the water, that's why seawater is actually a semiconductor, or it can actually conduct electricity. Okay, now these are 5 electrical insulators, and we've learned about this a little bit, right, from the properties of nonmetals. So here are 5 of them: rubber, glass, oil, diamonds, and dry wood. So these are all non-conductors. Okay, so today our focus will be just on testing these out using the circuit simulation software. Okay, so you're going to click on this globe and it will automatically launch or go to the website. Then you're going to click on this play button here. Okay, so feel free to either stop and pause this video as I go through it and then try it out as well. That way you have a little bit of instruction that's step by step, or you can watch this entire video and then launch this program and just try this stuff out on your own. Okay, so we're going to click on intro, and we're just going to more or less copy the picture that we have here. Okay, so we're going to make a gap in this circuit, and we're going to switch out these different items. Okay, so if when we put the different items and they're connected properly in a circuit, okay, if the light bulb goes on, this means that the item, for example, this dollar bill, it is conductive. Now, if the light bulb remains off, then it means that it is not conductive. Okay, I just got rid of some stuff on the side here, okay? Okay, so let's try this out. So we're going to do 2 batteries on the bottom. I'm just switching the orientation from what we did last class, but that's not a big deal. I still like to keep things in a nice rectangle, just to keep things neat and tidy. Okay, and we're going to bring this up over to here like this. So you're going to click it on here. It'll kind of snap on, and then you can elongate or shorten your wire. Okay, so these are all wires. Let's connect a light. Sorry, I think we'll put a light bulb over here actually, just so we don't have to turn it around. So let's go like this. Okay, we're going to put a wire right here. And then over here, we're going to snap it in here and then pull it over here. Okay, so we have a little gap here. So we tried out most of these items. Don't worry about the resistor, okay? We may or may not talk about resistance in another lesson later on, okay? Let's just scroll down. So if you press the arrow once, the down arrow once, we've already done wires. Don't worry about fuse for now, okay? Oh, sorry. Let's just actually check out, okay? Let's make sure that our circuit is connected properly, okay? So right now there's a gap, which is why it's not lighting up. But once I close it, it should light up because this is the most basic circuit right here, okay? So that's good. You just want to check and make sure that your circuit is running properly, even without the items in the gap right here. Okay, so if you remember, you click on the joining part and you can cut the join. Okay, and we're just going to make a small gap right here, and let's try out this dollar bill. Okay, so first of all, let's make a, not a hypothesis, but let's just guess. Okay, do you think this dollar bill, which is like, let's just say an American dollar bill that's made of paper fibers, are paper fibers metal or non-metal? Okay, so paper is a non-metal. So are non-metals generally conductive or not conductive? Well, let's see. Okay, so I'm going to click it in. So one of the ways of checking to see whether or not everything is connected properly is just by, because sometimes like you might have it like this, and then you think that everything is connected, okay? But you'll notice that once you move it around, it's not connected in the right place. Same thing as like over here, okay? Sometimes you might have your batteries like this, and you're thinking to yourself, hey, why isn't this working? Okay, but if you just move things around a little bit, you can see whether or not things are really connected, okay? So when things are properly connected, they'll actually shift all around together. Okay, so let's just try this out. Okay, now let's connect it here. It's totally connected properly. And look, the light bulb is not lighting up. Why? Because paper is a non-metal and the paper is not conductive. Okay, so if you click on the edge, you can cut it, okay, cut the connection. But if you want to get rid of the item, you can just click on the item and then press delete, okay, or garbage can. Okay, let's try out this next one. So this is a paper clip. So paper clips are made of what type of material? Well, they're made of metal. So is this going to be conductive or not conductive? Okay, take a guess. Okay, and then let's try it out. Great, okay, good. So this paper clip is made of metal and metals are conductive. Okay, let's get rid of that. Okay, here we have a coin. So coins are also made of metal. So what do we expect to happen? Well, if it's made of metal, it should be conductive. So it should be yes, conductive. Awesome, okay? Let's try out another one. Okay, so when we get to the bottom of the list, you can just click on the down button here. Don't worry about wire. So we know that wires are conductive, right? So here's an example of like, hey, it looks like everything is touching, but no, it's not joined properly. Okay, we have to make them connect like that. Okay, so wires are conductive, but we already knew that because all of these copper wires right here are wires as well. Okay, next up we've got an eraser. So is an eraser conductive or not conductive? What do you think? Okay, so this is made of rubber, and rubber is not conductive. Check it out, okay? It's totally connected properly, but it's not lighting up. So that means it is not conductive. It is an insulator. Okay, let's try this one out next. Okay, so we have a pencil here. So back in the day, pencils were actually made of lead. Okay, so this is actually a lead pencil. Okay, so I'm going to go over to the periodic table of elements. Okay, so where do we find lead? Well, lead is right over here. Okay, and lead is actually a metal. Now, it is close to the staircase, which divides metals on the left-hand side from the non-metals on the right-hand side. Okay, so what you'll notice is that the items over here, they are still metals. So lead is in fact a metal. Okay, so Pb is lead or plumbum. Okay, so it is a metal. So we should actually expect that a traditional lead pencil might actually be conductive because it is made of metal. Okay, so let's check it out. Okay, interestingly enough, okay, it actually resists quite a bit of the electricity flow. So it has actually quite a high resistance. And resistance is another topic that we may or may not get into. Okay, but check it out. Okay, when I get rid of this, so first of all, this lead pencil is made of metal, which is why it is conductive. Okay, so I'm just going to get rid of this though. Check out the brightness of this light bulb. Okay, think of that. Remember what that looked like compared to this. Okay, so the fact that now it's burning a lot brighter actually tells me that the lead pencil does not let the electricity flow as well as, for example, a copper wire. Okay, next up, here we've got a hand. Okay, so think of your skin. Does your skin actually conduct electricity? So could I make wires out of my skin, for example? Okay, so I just want to make sure that everyone understands being electrocuted by like an electric shock, okay, that is different than passing electricity through. Okay, passing electricity through you in order to conduct electricity. Okay, so just because you can get electrocuted or receive a shock and there's actually a discharge of extra electrons going through you, that is actually different than conducting electricity in this sort of a context. Okay, so it might be a little bit confusing because I think that students might think, oh, because I can be electrocuted, I could actually also pass electricity in this circuit. Okay, but let's just check this out. Okay, this might be surprising to people. Okay, so in fact, skin is not a good conductor. Okay, and I just Google searched it just to make sure, and skin is not a good conductor. It's actually an insulator, which is what this shows us. Okay, so in a lightning strike, that's actually like a different electrical phenomenon. Okay, so please don't be confused. Okay, similarly, let's do the last one, which is a doggo, okay? So this dog has fur on it, and I think I'm thinking to myself, well, fur is definitely an insulator, and then underneath the fur is also skin, for example. So I also expect that this should be an insulator, so not conductive, okay? And in fact, it is not conductive. Okay, so that's the gist of today's lesson. Okay, so we kind of like summarized metals are good conductors. So is seawater, okay, because it has dissolved metals in it, dissolved minerals. Everything else all the other items that are non-metals, generally, they are poor conductors. They are insulators. They are non-conductive. Okay, that's the gist of today's lesson. Please do try it out on the phET website. This just reminds you of conductive versus non-conductive and how you can tell, okay? And then other than that, once you've kind of had a chance to try out that simulation, okay, when you feel ready, please just click on the link that's on your PDF file, and it'll take you directly to the quiz's assignment, conductive versus non-conductive materials. Please remember to sign in with your TDSB email account so that everything will be updated to the Google Classroom automatically. Okay. Alternatively, you can also click on the link in the Google Classroom, and that will also be linked as well. Okay. Everyone, you're all doing a really great job. Please don't stress about any of this work. Do what you can. Like if you can motivate yourself to do this work, do it. Okay. But please don't stress out about it. I know that everyone is dealing with a lot of different things at home. Okay, everyone, take care and see you on the next lesson. Bye bye.